All right, today I want to back up just a little bit and talk about how types are handled inside of the workbench, specifically types of data that are moving between the different nodes. If we pull up a language model just to take a look at here, this is kind of a thing we refer to as a node in the workbench. And you'll notice on the left side here all of the inputs that are currently configured and possible to connect things to for GPT 4.1 Nano. And on the right, we got the outputs. Each letter and color here helps describe what kind of data that part of the node is expecting. So for the system prompt, it's expecting a string or a message, which I'll talk about in a second. For temperature, it's expecting a number. So begin to recognize these different colors and symbols as a quick at-a-glance way of understanding what the different types are. Let's see that in action a little bit in a more simple example. We'll grab just a standard number slider here, and maybe we will just output it to start. There we go. We're outputting 43. Now you notice that 43 is red, which matches the red here. It's not in quotes, so it's being output as an actual numerical type. If I check the raw logs of that output, we can see here in the response, let's get rid of our request body and timeline, data 43. That was output right there. So it's coming through as an actual number value in this, which is different if I grab a string, type 43, connect that string to our output. Now we've got a string. Whoops, there we go. Let's try that again. There we go. Now that ends up being in quotes is blue, which is what the kind of default color to communicate string is, and it's different, obviously, than the number, red. Similarly, if we come check our logs, grab the most recent one, I can actually just look at the outputs. Whoops, there. 43. Now we have it in quotes. So this is a string value of a number. Now, inside of the workbench, as you're wiring things together, you'll notice different colors and symbols that show up as you're connecting things. So this green line means that data flowed, in the last time I ran this, from this node to this node, and actually had data go through it. That thing did fire. This kind of black question mark means that this input can accept any value. And there's no real type checking happening to make sure that what you're connecting to the data output is something that is supported by that thing. Now, if we pull up something that does math, like an addition node that just adds two numbers together, you'll see we're expecting a number A and a number B. Well, if I connect that to there, and there to there, and let's get a data output, everything's happy, right? We just added 43 to itself. No problems at all. If I get rid of these and connect to string here, you'll notice I don't get that little magnetic helper. So here I'm getting this kind of partially gray line on the rest of it. And if I let go as soon as that line appears, it's going to just connect the link for me, because it kind of just assumes that that's where we want to go. If these are further apart, you have to kind of get a little close for the link to show up. You see that? Once it kind of knows where you're going, then it'll offer that helper. However, if the type doesn't match, or if it's not compatible, we don't get that helper. Now that doesn't mean you can't try. If we actually drag it all the way across and let go on the actual input here, we can still make the connection. We then have this red link showing up to help symbolize that these types aren't compatible. We're expecting a number, we're providing a string, it shouldn't work. Now in some scenarios, inside the actual engine behind ZeroWidth, it'll attempt to convert the value it gets if it's the wrong value type to the value it's expecting. And if that works, it might still handle it. So let's just change this to, or here, we'll make this easier so that our output's going to change. Run that, 47. So it parsed the 43 as a number and then handled the addition after that, right? There are other data types in the workbench. Most common kind of primitive data type would be a Boolean. I'm going to leave those numbers up there for now. I'll get a new data output so we can just see how this works. Right? We've got false. If I just click on this switch, now I've got true. Now, why would I use a switch like this? Well, I can use that to control different bits of logic in the workbench. And this will come back to language models in a second, don't worry. If we just grab an if statement, I can use this as a little switch here. Let's disconnect our link underneath there. So if this condition is true, then I want to pass 4 out the other side. So we should see 4 there, right? If I turn that off, we should end up, oh, it didn't update, right? We've got no green line here. So no data actually went through to update this output when I turn that to false. If I provide another value, maybe we'll provide our 43 string as the false value and run this. Now we're getting our 43 string. So our if statement now has an else condition that I can toggle this, and now we'll get 4. So I can take on the if else node a Boolean condition to use it as a switch between two any typed values, a true value and a false value, and output the result. And then I also have these helpers of did the true path fire or did the false path fire as another way of just double checking what's happening behind the scenes. But you'll notice on the if else node, we have no idea what data type the true value is. We have no idea what the data type that comes out the other side might be. So instead we have this other kind of link, this dash link, that we don't know if these things might be compatible or not. Unsure. Now in this case we've got 2 question marks, so it's any and any. So we should update this probably in a patch to make it so that line is solid, because if the value of any is being accepted, then this should be accepted here. But if I were going to do another math node first, now that makes sense. So we get the hint that, the yellow color here is communicating the any, and the dash here, my apologies, is communicating that this value might not fire at all, which is what happened when we had nothing connected to else, or to the false, and we switched this to false. Like no value came through this, right? That's when data didn't update at all. If I clear this all the way out, we can see this again, right? That dash line is essentially still possibly disconnected, right? But the black color is showing that it's valid. Sorry, I misspoke earlier. Let me switch that back with a number. And now we have both the dash line saying maybe this will pass data through, maybe it won't, depending on what the condition is set to, and depending on what's passed here. And the yellow signifying these might not be compatible. Where here in the workbench, we know this is a string and we know this is a number, so it's high length. This probably won't work. And we're trying to handle these situations to make it a little easier so that we can kind of numberify things, parse things as numbers where possible. But in this instance, we don't know if what's coming out of here might be an object or an array. And in that instance, it just won't work with a number input. So we have this yellow signal and the dash line, right? We don't know what that value is. It might not work. And the dash line meaning it might not fire at all. So again, if I switch this to true, you'll have this all fire, and we'll end up with our number outputs again, right? All right, so now why does this matter for a language model? Well, maybe let's clear all this out. Let's bring in a cheap, easy model just for testing. Let's connect some input chat setup here. So there we go. To messages, let's set up our output chat. And then maybe what we want to do is try out 2 different versions of a system prompt. So I'll get 2 system prompts out. I'll get our if else. Where is it? There we go. We'll make this one the true value, that one the false value, take the result and pass that to the actual model itself. And we'll get a little Boolean switch and connect those up. So let's add 2 example prompts here. Oh, assistant that platform. You are a honey advisor to the user's financial planning situation. So if I make this true and I say hello to our model, we're going to be giving the model, let's see if we can get a more specific answer from the model there. Looks like your message might have a typo. All right, let's try again. What's going on? Are we not getting the whole message? Very slow GPT 4.1 today. There we go. All right. Now it's responding. I can help you navigate the Zerwith platform. So clearly it got this system prompt, which makes sense because we connected that to true, and this one is connected to false. So let's switch that to false, and let's delete this and all of this, go all the way back, and let's try to get it to answer this first try. Now we're our friendly punny advisor. Now, not that that's something that I would particularly want a language model to do, but you can see we now are switching between two different configurations of a given model system prompt. Now, this is something I'm just controlling and tweaking in the actual design process of getting this set up, and I'm using the Boolean switch here as just a helpful tool so I don't have to rewire things, right? Otherwise, I'd be dragging this back and forth as I'm trying different outcomes. But we can also have other things create Booleans. We can compare input data. Maybe we want to have a completely separate context that comes in along with the user's messages that is like what kind of user this is, or what part of the tool are they talking to, or where are they currently on our website, and use that as some kind of parsed aspect to switch between prompts, switch between various models, switch between complete configurations, or maybe if we want to, we'll parse the message and check it against something like the Omni moderation model from OpenAI, which we can use to actually flag against maybe not messages we won't want to handle that are either violent or harmful in some way, and use that to generate a Boolean to respond with a canned message instead of prompting the model. So there's a lot we can start to do when we understand the different types of information that are moving around the workbench, and how we can use those as a part of the design process here, or make a more complicated or specific interaction happen depending on data or context. We can even have a complete separate language model output a Boolean that we want to use to control the flow of a later model. So we'll get way into that as we start to get into more tutorials here. I just wanted to talk a little bit more simply about these different data types first, and I'll get into the weeds more with messages and tools in later videos, but hopefully this helps start to explain when you're in the workbench some of the different colors, dashed lines, and design patterns we're trying to keep consistent as you interact and move around. So thanks for watching. Please subscribe. Stay tuned as we're getting close to the public launch of the workbench. Links to the Discord are below. We also have a newsletter that we put out usually weekly. Feel free to reach out to me directly or hit us up on our contact email or find us in the Discord, and see you tomorrow. Thanks.